Hi, I'm Philip, and in this video I will show you the scanning workflow of the Einscan Rigil on the device in the different modes. So in the regular marker laser mode, the markerless laser mode, and the infrared mode. And I will also look at the post-processing, like how does it work on a device and how is the speed compared to post-processing on a very capable workstation, I would say. So my workstation has 16-core AMD high-end processor and 128 gigabytes of RAM and a RTX 5070 Ti. I will try to capture the screen of the Rigil also by screencasting it to my notebook. There may be some dropouts sometimes when the Rigil is like in the processing and on a very high workload. It seems to like pause the casting sometimes to like focus on the actual processing task. So I would more like call this a feature than a bug, but let's get started. As you can see, I have my trusty skull here. And before I continue with the scan setup, let's unpack the Rigil or unbox the Rigil. I have the Rigil with my own designed protective case and protective covers. So there are these two PTG covers with Velcro strips that are used to protect the screen and the emitters while transporting. And then there is like a rough and printed from rubber protective case around this, the emitter unit, I would call it, and the display unit, and also here at the bottom of the handle. I've also recently made a video about how I designed this one, and I quite like it. But let's boot it up, place it to the side, and then look at my scan setup. Again, I have my skull. It's a plastic skull, so it's no real human skull, as some may have suspected, or some people actually suspected. I placed it on my turntable and I placed marker geometries around it. Normally, I try to not use the turntable too much anymore, because when rotating around, the part can slightly move. It's also a quite cheap turntable, I must confess. So this may be one of the reasons why the part may move, because it's not completely smooth and rotating. The alternative way is to use my marker cards. They are black aluminium business cards with marker point sticks on it. You can also buy some pre-made cards from AirSub, I think is the brand, but I just like bought 150 of the cards for 10 euros on Amazon and glued markers on it while watching a Netflix series. On the skull, there are also some marker points used for alignment of multiple scans, and I will need to do 2 scans of the skull. So one from the top side of the skull, and then one with the skull turned around, but more while scanning. So the Rigil is booted up now, and the first step is now enable the screencasting. With the Rigil, that's quite nice. You can screencast over either Wi-Fi or with the hotspot of the Rigil, so you don't need to have an existing Wi-Fi network. And it's not like only regular mirrorcast, as I will call it. It's actual proper, it's more like the Rigil creates its own web server. So on other devices, it's more like the Rigil. Let's wait for there it is, the Wi-Fi network. And other devices only offer screencasting to like smart TVs. On the Rigil, it's actually need to enter my Wi-Fi password, it seems. Okay, let's now first look up the password, as Sally having connected it. Okay, the password is Einscan Rigil. So this is the default password that is set. So now I think I can just cast. What's even nicer with the casting, so currently on my notebook, it's the hard way, I would call it. As you can see, there are just QR codes you can scan with your smartphone. So if you're on the field or in a workshop environment where you want to scan cast to your tablet or to a smartphone, you scan the first QR code to join the network or join the hotspot of the Rigil, and then you scan the second QR code to actually receive the screencasting, because you just enter the web address that is shown on the Rigil, And then, sorry, I must first enter the address. So the Rigil hosts its own web server, and you just visit the website of the Rigil, I will call it. And here, now let's start the screen capture on a notebook. And here you can see the screen recording of the Rigil. So now this is running. And for scanning, generally speaking, the modes are quite similar by scanning. So you have to pay attention on the same things. So for the infrared mode, maybe let's start with the infrared mode. You have multiple settings. So you can either select if you want to scan an object or a portrait scan of a person. Here we have an object. I would call it a small object. And you have here the resolution setting. On each of these points, you can also manually override them. And the manual override is also saved. So now, as you can see, the override is saved. So you can create your own, I would call it, slider options. In infrared mode, you also have the option for multiple tracking methods at once. So you have the feature alignment, you have the texture alignment, and the marker alignment. For the scanning speed in standalone mode, maybe a rough guideline. So in the only feature alignment, so if you're not using hybrid tracking, I very constantly reach 20 FPS. If I use hybrid tracking, so with the texture alignment and with marker alignments, sorry, it seems like you only can use 2 of them at a time. Actually, haven't tried with all 3. You're more like, so with texture alignment, you're more like at 10 FPS. So if I scan like motorcycles, I actually prefer only using the feature alignment. It's good enough, so you have an incredibly large field of view, especially at the scan distance of up to 1.5 meters. So here in the small mode, we are limited to 1 meter distance. But since the head is so small, I will cut it down even further. And what's very nice, so in the large mode, so if you go back to large mode, the Rigil supports 6 millimeters and 12 millimeter markers. So this is quite huge for me, because previously with the Rocket, it was like this. So in the infrared mode, Rocket only supports 6 millimeter markers, and therefore the maximum scanning distance is limited to 600 millimeters. So I initially wanted to use the Rocket for scanning car bodies, but if I'm limited to 600 millimeters anyway in IR mode, I could also use laser mode, and then I need a lot of markers. But now with the Rigil and the 12 millimeter marker support, I can now use the full 1.5 meter of field of view scanning distance. As you can see, I can capture like a very large field of view. I think it's roughly 1 meter by 1.2 meters, and therefore I'm not needing a lot of markers. So next week I will also scan some car bodies with the Rigil. So first with the 12 millimeter markers, and I'm already quite excited to see how it performs. But for the scanning, so I will use hybrid of feature alignment, marker alignment. In the IR mode, I generally always use the automatic exposure. If you are using marker alignment, you cannot set automatic exposure on the IR camera. So there you need to use the manual exposure. But what's quite good, so I think you're not seeing my interactions, but here in the Rigil, if I want to edit the exposure, I'm not only limited to this very small slider, I can just use the full area of the camera preview to slide up and down. So this is a very nice feature. And then for scanning, I will now limit the scan distance to maybe 450 millimeters. I will enable the removal of the base plate to simply limit how much data I capture. And what's always quite good, if you want to scan and the base, so while scanning, the most relevant information for myself is, did I already capture enough data? And for this, the default setting is the texture display. So you have a real-time preview of the texture of the part, but to see if you scanned enough, you need the data quality indicator. And then I can just, like this, start a scan. and simply move around the head. And as you can see, I'm currently at 0.5 millimeters of marker or point distance, and it's basically capturing the data in real time. And as you can see, I'm basically already finished with the first side. So yeah, but now let's delete the data. So for the post-processing, I will simply use the regular laser scan in the marker mode, because the processing workflow is similar for all different modes. But first, before we capture the laser mode, I will use feature alignment. So what's quite nice, so here we are now in the settings for laser mode. I will use 0.5 millimeters of resolution, simply because I'm not interested in the quality or the high detail of the scan now. I just want to focus on the post-processing workflow, and then the capture is a bit faster. But I will also upload a high detail scan, I will call it, on Sketchfab and on social media platforms to see what the scanner can do. Currently in marker mode, you can also use the feature alignment mode. In feature alignment, it's basically like using the IR scan for tracking and then the laser lines for scanning. And with the recent updates, so this is maybe a first. And so I think 1 week ago, they finally released the new 1.2 firmware update that enabled the markerless laser scanning standalone on the device. So previously, right at launch, you could only use the markerless laser scanning in wired connection to the PC. Then the first update allowed it with wireless connection to the PC, and now you can do it on device, and it's even quite performant. So you can see we're at like 22 FPS, and they also increased the laser line count. So from I think it was 38 laser lines in the beginning to 50 laser lines. So they didn't magically add the laser lines; they were there all the time, and they just enabled the software processing, and then I guess they still had to optimize some parts. For the markerless laser scanning, it's really similar to the IR scanning, with the limitation that you are only using the texture tracking. So I don't know, maybe they will bring hybrid tracking in the future for this mode, but currently it's only feature tracking, and therefore you have the limitations of feature tracking. So if you have this flat table, in texture tracking or hybrid tracking, it will work, because the wood texture, the wood grain is unique, a unique pattern. The feature tracking won't work unless you have very carved up ancient wood. It's like the scanner is also using an IMU, so integrated measuring unit. It's basically measuring the acceleration and the movement of the scanner for better tracking or to prevent spinning. So I guess this is the cause, because if I now not rotate the turntable, the tracking is vastly improved. So it doesn't lose tracking. So my explanation is it is using an IMU for tracking. So maybe I need to increase the brightness a bit. So now let's see if we can regain tracking. So here we have the tracking again. But as you can see at 0.5 millimeters, it's also quite fast in scanning. But this is only the starting. So the main scan I will be doing now is in the marker mode. So let's switch to marker alignment and do the scan. So maybe let's reduce the exposure a bit. So this should work, and I can just start scanning. You can also acquire texture in marker mode, so directly in laser mode. It's actually working quite well, so the texture quality is very good. But for this scan, I'm not needing the texture, so I'm not seeing any benefit in capturing the data, because it quite makes the project much larger. So this is always one point. So the Rigil has 1 terabyte of SSD storage, so this size is not a problem, but at some point my PC at home is limited or my workstation is limited. So there's simply no use in scanning like this unnecessary data. For switching the laser line modes, you just press on the mode button, and it's quite fast in switching. So maybe now you need to move a bit closer. So in parallel mode, you need to get quite close to the part. So this is one thing I initially missed a bit. And actually, the optimum scanning distance is also dependent on the resolution you choose, on the scanning or the target point distance you choose. So this was one of the problems I had with the rocket initially, that I thought that scanning in high resolution was very slow. But actually, I was too far away all the time. Now, let's see, the first scan seems to be finished. So I guess I captured enough data. And now I can directly delete the base plate, and then we continue with the second scan. For this, I just use the lasso selection tool, as you can see here. And I can quite nicely interact with the scan like this. So yeah, confirm cropping, and this looks good. So I can now turn around the head and continue with the second side. It automatically started a new scan inside the project group. And for turning around, I will use a bit of blue tack just to ensure that the head doesn't wobble when it's turned around. So this can happen because the face isn't exactly flagged. But I must confess that blue tack may not be the ideal solution. So previously I have noticed some problems with blue tack, that it tends to deform a bit under load, and this is very very contra beneficial for scanning, because as soon as the part moves while scanning, basically your scan is ruined. So keep this in mind. I'm currently working on or currently testing a few better options, but for the moment blue tack is still my main choice. And now it's looking good, and I can just start with the scanner again. And I'm getting now 50 FPS in the 50 laser line mode. So this is quite impressive. So I was very surprised when they announced the update, or when I've seen the increase of laser lines. I first thought, okay, cool. It seems like they bring out a new hardware generation, maybe a 1.2 hardware generation, and it's like an upgraded version or a refresh. But no, it's actually only a software update. So this was this made me very happy, and I had to see it with my own eyes. So when I got home, I quite rushed the update to actually check out if this is only the software update. And luckily it was. So, and I must say the tracking is very good on the Rigil. So I don't know if they're also using the large cameras for the infrared mode for tracking in the laser mode, or maybe at least in the markerless laser mode, because in comparison to my rocket, the performance in markerless laser mode is drastically improved. So it's not only faster, but also much better in tracking. This could also be due to the supposed IMO that I guess is present, but who knows? So maybe I have to ask the support nicely if they can give me some insights. And that's quite nice. You get this enlarged preview of the selection tool. So for selection, as you've seen, there is a regular rectangle selection, but there is also the lasso selection, and I most of the time use lasso selection because with the opening there is a straight line, and this is very nice for removing base plates. And for the rectangle selection, you only have the rectangle oriented to the vertically. So you first need to orient the part. Okay, so now this looks good. So I guess we can first do the fusion of this part, then we come back for the fusion of the second part and look at how long it takes. So after fusion, the next step will be alignment. With the Einscan latest update of the Rigil, they actually added the functionality for on-device alignment. Currently the alignment only supports marker mode. So we now, as you can see here, I can now press the alignment button, and then we have the two views. So we have the first side where I can select project 1, and then the second side we can select project 2. And what we now do is either automatic alignment or manual alignment. Automatic alignment won't work here with mark alignment because for the automatic alignment it would try to align the base plates to each other, because there's like the largest overlap of markers, whereas the markers on the skull itself are only very few. So we now switch to the manual alignment. And for manual alignment, you basically just pick out your common markers and double press the markers. So initially I was wondering a bit about how to select these markers. It's just double clicking, like this. You have to aim a bit if you have clumsy fingers. So now there we have 2, and I think on the forehead this will be the third marker, and this then should work for alignment. Now let's see. It is already aligned, so it looks quite fine. So we can now confirm. It would now even allow me to continue alignment with other markers, so with other scans. But since you only have 2, I can complete now, and I have the merge group. So in the merge group, the next step I can do now is the actual meshing. For meshing, I will again do like my default settings, and I will remove small floating parts because I have some around the skull here, and with the removement it will just delete all of them. So now the meshing is finished, and I can press on complete, and let's have a look at the final mesh. It looks quite good. Maybe on the here on the screencasting it may not look ideal, but what we now can make, what we now can do is actually alignment to the coordinate system here on the Rigil itself. So I will of course also export it to my PC or in the whole project to see how fast it processes on the PC. But now we can do alignment, and this is quite cool. So I haven't seen other standalone scanners that feature this this option. And now we are in the alignment tab. And how you have to understand it, or how do you use it, is basically you have the 3 views of the 3 planes. So you have the front plane, you have the right plane, and the top plane. And on each of these planes, you can now do 2 operations. You can either rotate your part around the axis of the plane, or you can move it in the plane. And basically you go round and round for the 3 different options to slowly align the part to the coordinate system. I would say for like touch operation, this may be the most intuitive option. So I'm not really seeing like point picking or plane alignment in a touchscreen. But for a rough alignment, this is working very good. So as you can see now, maybe let's rotate it a bit more like this, and small movement, and a small movement now, like this. Now we can move it, and I would say it looks quite fine. So now let's complete the alignment, and it looks good. So for exporting, you now have 2 options, and both of them are quite handy, I would say. So the first option is the efficient way. So if you already did all of the post-processing on the scanner itself, you can now just add the finished mesh file to the PC or to the device. Now let's name it skull. And if you now edit like this, it is permanently saved in the scanner. And what you now can do is enable the USB drive mode. With the USB drive mode enabled, the scanner behaves like it behaves just like a USB flash drive. So now if I plug it into my PC, we now will see a pop-up. So, and we can open it in the File Explorer. Here's the Rigil, and under Models, Skull, I have my STL file, which now will drop into my my desktop. And so this is currently a USB 2 cable I'm using, so it isn't as performant, but I guess it's fast enough. And the next thing, yeah, you can see here, okay, it's a non-USB 3 connection, so it's not very happy. But I now can move the whole scan project to the PC. And for this I will, I now have to move it to my PC, and I will continue on the PC screen, because as soon as I enable the connection to the PC, the screencasting is disabled. I'm seeing my scanner is already connected over Wi-Fi now. So I just clicked on the connection to PC button, and it's connected. And you have basically like the option now to create an eScan with Wi-Fi scanning. So with the latest update, it's now up to 110 FPS in laser mode. So it's quite nice. So depending on your Wi-Fi environment, maybe a bit slower. So it's maybe like you may lose 10 FPS depending on the environment. But what you also can do is just go into the file manager. And what you're having here is all the scans that I'm currently having on the scanner. And here is my skull scan. So I can now directly import the whole project. And it's just pulling it over Wi-Fi. So as you can see, it's like roughly 20 megabytes per second. So this equals to roughly 200 Mbit Wi-Fi speed. So if you have very large projects or want to import a lot of projects at once, you may want to use the USB cable, but keep in mind for the USB connection to use a USB 3 cable. So ideally, of course, the cable that came with the scanner, but any other USB 3 cable will also work. For scanning itself, I personally wouldn't use the USB connection, because I simply don't want to damage the USB port on the scanner while handling it or while moving the scanner around, and the Wi-Fi connection is stable enough and works like basically the same as the wire connection, that I don't see any real reason in using the USB connection for scanning, aside from maybe like you are in some special environments, I would call them, where you aren't allowed to have like RF emissions, or you have a very noisy RF spectrum and the Wi-Fi connection isn't working. But then again, maybe it's a point to just scan on the scanner itself in standalone mode and then move the files to the PC later. So I just now imported the project. What I will also show you now is what's even nicer, I think. So if you already edited on the scanner, you can just open the project group like this, and you directly have the mesh here. You can see it, and you can also then select it, or you can now selectively export it as a STL file. So this is quite handy, I would say. So you can now here, you have the two point clouds you can export as a P3 file, but you can also directly export the mesh file. So quite handy if you don't want to have all your raw data on the PC again. Me personally, I just always import the whole project. For the on-PC processing, I now just opened the project on my PC, and here you can see the two single scans again. And first thing I will be doing before processing is I will isolate the relevant data. So I'm still having like these small outliers. The easiest option to get rid of them is just using the connected. I first need to use generate the point clouds for both scans. So just select both of them, and you can generate point clouds. What's quite cool or quite nice, I would say, is that the ExScan Rigil software is actually the only software that's like really using all CPU cores with all the might they have. So I'm having a 16-core processor like the Ryzen 9 7950X, and in very large scans, I'm like feeling my PC hang a bit because all cores are under 100% load. So I haven't encountered this behavior in other scanning software. I would say this like maybe is a bit of the optimization done for high-end PCs on the Shining 3D side, whereas in other companies, they may focus a bit more on the customer consumer-grade hardware. So in the top-tier hardware, it may not benefit anymore. But now let's isolate, let's get rid of all these like smaller outliers here of my marker geometries. For this, I'm just using the paintbrush to select my scan here, and then I can use the connected domain option. So now let's invert it. So all unrelevant data is selected, and I can now delete it. I will do the same for the second side. So for the downside scan. But what I also will do is get rid of the, I would say the fuzzy scan data to the edges here. So this is one problem I know I sometimes encounter is that if I scan parts upside down, where you're having like this very sharp angle or these overhangs, the data can get a bit fuzzy, and oftentimes it's just getting better results if you are deleting data or like the fuzzy data anyway, and then with the second scan it will be still covered, because then if you wouldn't delete it now, there is like the risk of having like a bit of a streaky surface of the scan. For general reverse engineering, it's not very bad, but why make life harder than it needs to be? Okay, so I just did a quick realign on the PC again, and now we can also go into the meshing. I will just use the default settings and the recommended parameters, and let's now see how long the meshing takes. I guess it will be quite a bit faster than on the scan itself. And yeah, it is quite fast. You of course see the 0.5 millimeter resolution in comparison to the to the higher resolution scan I will show you in a second. But I would say it looks quite nice. And of course in the proper software, so not in the standalone version, we have a lot more of post-processing options. Like we have mesh optimization, where you can do a bit like what's called adaptive smoothing or simplification. We can do a general simplification. We could adjust texture if you would have captured it. We can fill holes, and of course we can do more advanced alignment. For this, I will just use the simplest alignment version that is there, and it's basically the quick alignment. By just oriented the scan in the facing forward direction, and with pressing align, I can just create a first alignment. And I would say this looks quite good. And now let's compare the 0.5 millimeter scan to the 0.1 millimeter scan. So now let's compare the scan results. Here on these two scans, they are actually quite a different case than the 0.1 millimeter and 0.5 millimeter scan. On the left side, we have the scan that was meshed on the Rigil and standalone mode. And on the right side, we have the scan that was meshed in ExScan Rigil on my PC. For both, I used the default settings. And as you can see, I would say the PC version is a bit smoother. And especially like here in between the teeth, we have more separation on the PC version. Also like the, I would say, texture here on the skull is a bit different. So this is just my 2 cents on this. But the more interesting one, I would say, will now be looking at the difference between the 0.1 millimeter and 0.5 millimeter scan. And I guess it's quite clear. So the 0.1 millimeter scan obviously has way more detail. So if I just do like a slight orbit around it, you can see that all these like cracks in the skull are, or the connection between the bone plates. much more defined on the 0.1mm scan, but I would actually say for like general use and general reverse engineering tasks and mechanical parts, 0.5mm is still enough resolution for such, I would say smaller parts. But this is just a quick comparison. I will especially upload the 0.1mm scan to Sketchfab so you can get a feeling for the quality of the Rigil.